Welcome to EC Concept. This is the continuation of short note on RCC. So today we are going to see about the compression member. Okay. So compression member, also call it as a column. Okay. Okay. Here, first of all, we are going to see classification of column. Classification of column. Okay. Classification of column. First one is based on type of seal. A or the first one, classification of column. In that we can see first one based on type of seal. Based on type of steel used. Based on type of steel used, in that, so or you can take it as this is A. In that first one is tied column. Tied column. Second one is spirally or helically reinforced column. Spirally or helically reinforced column. Reinforced column. Third one is a composite column. Third one is a composite column. Okay. Here the tied column, in the sense, there are three types of column. One is a tied column, another one is a helically reinforced column, third one is a spirally reinforced column. Okay. Now tied column is the column which is made up of by using ties. The column which is made up of using ties. Okay. So this is the tied column. Okay. Okay. So these all are called lateral ties. So this is lateral tie. Okay. Now the spirally reinforced column. This is the column. Okay. Column. And spirally reinforced. So this is the spirally reinforced column. Okay, spirally or helically reinforced column. The last one is a composite column. So in that composite column, I can able to draw the cross section. So this is the cross section. So this is the cross section. Okay, and in that this is the composite column. Okay, so this is the composite steel. Okay, so we will use a composite bar here. Okay, so this is the area of composite. This is the area of composite. This area of composite material, area of composite material should not greater than 20% of AG. So should not greater than 20% of AE. So this is the question for your state government examination or central government examination like SSJE, IES. They will ask you, what is the area of composite? The area of composite is should not greater than 20%. Okay. Now this is the based on type of steel used. Second one is based on type of loading. Based on types of loading. Based on types of loading, column is classified concentrically loaded. Concentrically loaded column means load is placed at CGR section. Concentrically loaded column means the load is acting at a CG of the section. The second one is axially loaded column. Axially loaded column. Axially loaded column in the sense load is placed at an eccentricity within the 5% of lateral dimension. Within the 5% of lateral dimension. Third one is axial load with the uniaxial bending. Axial loaded with the uniaxial bending. That is axially loaded column with one side bending also there. Third one is axial loaded with biaxial bending. Axial loaded with biaxial bending. So this example they maybe ask you. The example for this column is edge column. Edge column of framed structure. Edge column of framed structure. But this one is example corner column of framed structure. So corner column of framed structure, edge column of framed structure. Okay. So this is actually fourth one, axially loaded column. So this is the classification based on the type of loading. And C, next one is classification based on slenderness ratio. Classification based on the slenderness ratio. So that is, if the slenderness ratio, that is a lambda, if the lambda less than or is equal to 3, then we can say is a pedestal. If lambda less than or is equal to there is 3 less than or is equal to lambda less than 12, then we can say it's a short column. Then lambda greater than 12, then we can say long column. This is the classification based on this slenderness ratio. Okay. Next, we are going to see next topic, that is effective length concept. Effective length. Definitely there was a question will be come from this part. Okay. So what is the effective length? It is a length of column effectively participate in buckling is called effective length of column. So length of column is length of column, that is effective length means it is the length of column. We can write it is the length of column effectively participate in buckling is called effective length of column. Effective length of column. Okay, so here some of the formula that you have to, that means some of the value that you have to keep in your mind, very, very important. First one is support condition. Support condition, theoretical value, theoretical effective length, recommended by IS 456 2000. Recommended value. Okay, so the support conditions are support condition. First one is both end is pinned. Both end is pinned column. This is the pinned column. Okay, here the L effective is equal to L. Okay, and here also L effective recommended also L effective is equal to L. Next one is L in the sense total length of the column. And the next one is both end, one end is pinned, but other end is fixed. So this is the length of the column. Here L effective theoretical is equal to L by root 2. L by root 2 is equal to 0.7 L. But L effective recommended is equal to 0.8 L. Okay. Next one we can write this is L. And this is L. Now both end is fixed. Both end is fixed. So this is L. So L effective, which is equal to L by 2 theoretically. Practically, L effective is equal to 0.65 L. Okay. In the similar manner, we are going to use some more conditions. Support condition, theoretical value, and recommended value as per code. Recommended value. Okay. Now theoretical value and recommended value. So the support condition, one end is fixed, other end is free. So this is the length of the column. Theoretical value L effective, which is equal to 2L, and a recommended value also L effective, which is equal to 2L. Okay. Next one is one end is fixed and other end is held in position against rotation but not held in position due to translation. So this is the, so this is, we can write this side is, here rotation is 0, so we can write this is the held in position against rotation, not held against, not held against translation, not held against translation. Okay, so such kind of thing. Then we can say L effective, which is equal to L. Okay, and here also L effective, which is equal to 1.2 L. Be careful, recommended is 1.2 L. In the similar manner, here one end is fixed, other end is held against rotation but not held against translation. The last case is one end is hinged and other end is held against rotation but not held against translation. So the end comes like that. This end is meaning is held against rotation. Since slope at this point is 0, rotation and not held against translation. Not held against translation. So this is the thing. Okay. Now here we can write L effective, which is equal to 2 times the L. And here also L effective is equal to 2 times the L. So these values are, you have to keep in your mind because this is very, very essential for your examination perspective. Okay. Now, the next one is maximum permissible unsupported length as per IS 456 2000. IS 456 2000. In that, first one, laterally supported at the ends. Laterally supported at the ends. So here L unsupported should not laterally supported at the ends. In that, unsupported length should not greater than 60 times the B. Second one is laterally not supported, laterally not supported at the ends. Laterally not supported at the ends, in that L unsupported should not greater than 100 B square divided by D. Should not greater than 100 B square divided by D. So this is all about the maximum permissible unsupported length. Next one is the minimum eccentricity of a column. Minimum eccentricity. Minimum eccentricity of a column. E minimum which is equal to maximum of L unsupported, maximum of L unsupported, the whole divided by 500 plus B or D least lateral dimension divided by 30. And this is 20 mm, whichever is maximum. This is the minimum eccentricity of a column. Okay. Now, next one is here B or D is the dimensions of column. Here you have to take a minimum. Okay. So that you will get a E minimum. Now is a reinforcement details. Okay. That is a reinforcement details, longitudinal reinforcement. Longitudinal reinforcement, we are going to write now one by one. Longitudinal reinforcement. First one is minimum 0.8 percentage of minimum 0.8 percentage of gross area. Minimum 0.8 percentage of gross area. First one. Second one, maximum of 6 percentage of gross area practically 4 percentage due to lapping. If there is a lapping, then we will take only 4 percentage, but maximum is 6 percentage, minimum is 0.8 percentage of gross area. If there is a lapping, then we will take only 4 percentage. But generally in the option, if they gave for 6 percentage, then you have to take a 6 percentage. Okay, so this is the answer. Now, minimum diameter of bar, minimum dia of bar is 12 mm. Now, minimum four bars per rectangular, 6 bars for circular. Next one is maximum spacing along, but see rectangular section 4 bars, circular section 6 bars. Okay, maximum spacing along periphery should not exceed 300 mm. Maximum spacing along the periphery of the column should not exceed 300 mm. Okay, so that is important. And next one is minimum nominal cover is 40 mm or diameter of bar whichever is more. Minimum nominal cover is 40 mm or diameter of the bar whichever is more. Okay, and it can be, that means this 40 mm or diameter of the bar, which it can be reduced to 25 mm if the bar is 12 mm. If the bar is 12 mm and section bar is 12 mm and section dimension 200 mm or less, and section dimension 200 mm or less. Next one is minimum 0.15 percentage of gross area, 0.15 percentage of gross area for pedestal. 0.15 percentage of gross area is pedestal. So these are the longitudinal reinforcement. You have to keep this in mind repeatedly. These statements are asking. So this question is asked repeatedly for a state government examination as well as central government examinations. Minimum 0.15% of gross area for pedestal. For pedestal is a column, but the size is lambda cylindrous ratio is less than 3, right? Next one is a transverse reinforcement. First we having seen the longitudinal. Next one is a transverse reinforcement. So transverse reinforcement that we are going to see first of all. So transverse reinforcement, the first one is lateral ties. If we use a lateral ties, then phi greater than or is equal to maximum of phi longitudinal, that is a maximum size, divided by 4 or 6 mm. What is the meaning? Suppose if you use a 3 bars, out of 3 bars, this is the longitudinal bars, this is the longitudinal 3 bars. Out of 3 bars, maximum diameter bar you have to take. The maximum diameter bar divided by 4, that is the lateral ties diameter. Okay. Next one is, this is the lateral ties. Okay. Second one is spacing. Spacing of lateral ties. Spacing less than or is equal to minimum least lateral dimension or 16 times the diameter of bar. This diameter means longitudinal bar, minimum longitudinal diameter bar. 16 times the minimum longitudinal diameter of bar. This is 300 mm. Okay. So this is the transverse reinforcement, diameter of the transverse reinforcement, spacing of the transverse reinforcement. Next one is, we can write, next one is spiral. Okay. That is a second one is spiral ties. Spiral ties. Here, diameter of the spiral ties is maximum of 5 longitudinal maximum divided by 4 or 6 mm. Now, spacing per pitch. spacing per pitch less than or is equal to minimum of spacing per pitch 75 mm, or DC is the diameter of the core. Okay, this is less than, then spacing per pitch, if you use a spiral ties, then it is greater than maximum of 25 mm, 25 mm, or 3 times the diameter of spiral. Okay, so here DC is equal to what? DC is equal to dia of core. DC is equal to dia of core. The next one is that we are going to see is the spirally reinforcement column. Okay, before that, some of the point you have to write, we have to write in the transverse reinforcement. The first one is to prevent buckling, to prevent buckling of longitudinal reinforcement. So what is the use of this transverse reinforcement? You can write use of transverse reinforcement. First one is to prevent buckling of longitudinal reinforcement. That is the first point. Second one is to hold longitudinal reinforcement at its position. To hold longitudinal reinforcement at its position. Third one is for confinement of concrete. Fourth one is enhances resistance against shear and torsion. Okay, so these 4 points are the uses of using the transverse reinforcement. Okay, now all about the spiral or helical column. So about next important point is about helical reinforcement column. Helical, or you can say, is a spiral. So the spiral reinforcement column. Okay. Now, first point, concrete in spirally reinforced column, concrete in spiral reinforced column is subjected to triaxial compression. Is subjected to triaxial compression. This point is important. Concrete in spirally reinforced column is subjected to triaxial compression. Okay. Now next one is a column is considered as spirally reinforced only. A column is considered as spirally reinforced only if following conditions are satisfied. If following condition is satisfied. If following condition is satisfied. Okay, so the condition is this one. Volume of spiral reinforcement, the whole divided by volume of core greater than or is equal to 0.36 FCK divided by Fy into Ag divided by AC minus 1. Okay. So this is the condition. So here we can write what is Ag. Ag is the gross area of column. Gross area of column. AC is a area of core. Area of core. Okay. So this gross area we can write is a pi by 4 diameter of the column. This is equal to pi by 4 diameter of core of the column. So this is the dia of core. Dia of core. Okay. So this condition must be satisfied. You have to keep this condition in your mind in your examinations. Directly they will ask you this condition. Okay. So this is all about the helical reinforcement column. Now, assumptions in compression member. Compression member. What are the assumptions? So the first one is maximum strain in concrete. Maximum strain in concrete is limited to 0.002. Maximum strain in concrete is limited to 0.002 due to compression. Okay. Second one is if a column is subjected to axial load with the bending moment, axial load with the bending, and the entire section is under compression, then maximum strain in maximum strain in concrete is limited to 0.0035 minus 3/4 of compression, 3/4 of compression strain in least compressed fiber, Okay. So this assumption is important. So what they are saying, this point is, if a column is subjected to axial load and moment, this is the centroid. Now this point is subjected to force P and moment, bending moment P into E is equal to moment. Now this column, one side is subjected to compression, another side is subjected to somewhat tension also. But in overall, both sides are subjected to pure compression. Both sides are subjected to pure compression. Okay. Now in this case, for this case, that means axial load as well as bending moment. In that case, the maximum strain in concrete is limited to, in this case, axial load as well as bending moment acting case, maximum strain in concrete is limited to 0.0035 minus 3/4 of the compression strain in least compressed fiber. So in this fiber, right, this is the least compressed fiber, left side. Right side is the highly compressed fiber. That's why the stress is more. This is sigma max. This is sigma minimum. So in that, there was a strain, right? This fiber. In that total strain, you have to subtract, take 3/4 of the strain. Then you have to subtract that 3/4 of the strain from 0.0035. Okay. Take a strain in least compressed fiber. On that strain, take a 3/4 value, subtract the 3/4 value from 0.0035. So this is the assumption in compression member, main assumption. Okay. Now we are going to write the load carrying capacity. Load carrying capacity. The first one is axially loaded column. Axially loaded column. Then is a concentric loaded column. So axially loaded column and concentric loaded column. Concentric loaded column means there is no eccentricity. Axially loaded column means there was a eccentricity. Okay, minimum eccentricity that we are taking. Understood? So that is the important thing. For axially loaded column, PU, which is equal to 0.45 FCK into AG plus 0.75 Fy minus 0.45 FCK into ASC. Okay, this is for axially loaded column. Now, this is for tied column, axially loaded tied column. Next one is PU is equal to 1.05 0.45 FCK into AG plus 0.75 into Fy minus 0.45 FCK into ASC. This is for spirally loaded column. For spirally loaded column, we have to increase 5% of the value which is getting from tied column. The same formula only we are using here also, but we are increasing 5%. So this is all about axially loaded column. Next one is for a concentric loaded column, the same formula, small modification will be there. PU is equal to, instead of 0.45, we will use 0.4. FCK AG plus, instead of 0.75, we will use 0.67. 0.67 Fy minus 0.4 FCK into ASC. Okay. This is as per IS 456. This is as per IS 456 2000 for tied column. For tied column. But this value is equal to 0.4 FCK AC, area of core. This is AG, cross section area. This is area of concrete only. We have to subtract the steel here. 0.67 Fy AS. This AC means area of concrete, which is equal to total area minus area of steel. There is a gross area minus area of steel. This is for SP 16. Okay, this is as per SP 16. As per SP 16. So this is the concentric loaded column. Next one is PU, which is equal to 1.05, 0.4 FCK AG plus 0.67 FY minus 0.4 FCK into ASC. So this is for a spirally loaded column, ASC. Okay, that means into ASC. This is for spirally loaded column. The same formula only, but in the spiral loaded column we have to increase 5%. Okay, so this is all about axial loaded column, this is all about concentric loaded column. So only this much is enough, you can able to attend up to the state government as well as central government examinations. Okay,